An ASU-led initiative called EPICS aims to reduce CO2 emissions in the manufacturing industry. The goal is to reduce manufacturing CO2 emissions by up to 60 million metric tons over the next 15 years. For more on this, we welcome Sridhar Seetharaman. He's the Chief Executive Officer of EPICS. Good to have you here. Thanks for joining us.
Thanks for having me.
Give me a better definition of EPICS.
So EPICS stands for Electrified Processes for an Industry Without Carbon. So the X kind of crosses the C out. And we're aiming to reduce the greenhouse gas emissions that heavy industry emits. Industry in the U.S. emits today about 30% of all the greenhouse gas emissions of the nation.
Wow, my goodness. And this is based out of ASU, correct?
Yes, we're headquarters in ASU, but we're national, so our reach is all over the country.
And you recently got a Department of Energy grant?
Yeah, that's the foundation of our funding. So it's $70 million from federal funds, and that's matched by industry and other partners.
Okay, so where does the $70 million and the matching fund, where does all this money go? What are we researching? What are you looking at?
So we're looking pretty much to replace all the process heat used in manufacturing. So out of that 30%, the majority is just heating stuff up. Whether you're baking bread or smelting iron and steel, it's just burning of fossil fuels to reach the temperature you need to reach. We're looking to replace all of that with electric heating technologies to pretty much eliminate the greenhouse gas emissions used in all the manufacturing for those sectors.
So I saw everything from pasteurized milk to making cars. You mentioned smelting steel. I mean, it all needs heat, it all needs energy, and you're saying that energy means CO2 right now.
Yes, because you're combusting natural gas too.
Can you make that transition, though, to electricity? Does electricity have the power that you've already developed in these other industries?
So the technologies exist, so you can reach those temperatures relatively easily in the lab, but making it work economically is the challenge because you need the extra power, and there's a cost to power. And unless that power is originating from clean energy or nuclear, it's not really carbon-free either, right?
Right.
So you need to integrate the non-carbonaceous power into the factories. That's one challenge. The second challenge is, if you think about it, fossil-based heating has been used for centuries now, right? So it's been so optimized. So there's a risk associated with that replacement. Can you use the same raw materials? Can you produce the same quality products? And do you have a workforce to actually do it?
Yeah, that workforce is interesting. That's where your training comes in, and that's got to be part of the money here, right?
Absolutely, yes.
Okay, storage capacity, storage facilities, always big when it comes to renewables and these sorts of things. But in general, for heavy industry, how can that play a part?
It's a very critical part because industry, unlike vehicles or homes, industry have to operate 24/7 usually, and they require that power when they're producing goods, not when the sun shines or when the wind blows. So it's essential that the power is available when they need to make stuff, not when it happens to be available for natural reasons. So storage is kind of a buffer. If you can develop storage solutions to store the power when, say, there's high peak power, and then use it when you need to manufacture, that would buffer that problem, right? So a place like Arizona, that's absolutely critical, where we depend on sunlight for a renewable power.
Yes.
The alternative to that is, of course, nuclear that could provide you that steady state, but it's not yet deployed at scale.
Especially the smaller nuclear plants that we keep hearing about, almost community level, if you will. But is that even an option?
It is becoming an option. In Europe, in some places, they're starting to implement more nuclear. It might become an option here. Some people believe in it, but there is, of course, the stigma and public perception that still has to be overcome.
Department of Energy wants to cut industrial heat by 85% in the next 10 years or so. Is that doable?
It has to be doable if we want to achieve our climate goals. The challenge will be, is it doable at a cost where we don't lose our industry? Our industry has to remain competitive or become more competitive while doing so. We should not lose jobs by making industry less competitive. So can we achieve it? Can we achieve reindustrialization at the same cost as what we're doing now or better? That's the key.
Is what we're doing now, how much has it improved, or has it even improved at all over the years with all this concentration and attention to climate change, global warming, et cetera?
There has been advantages over the last couple of years, but it has not been fast enough to achieve our goals. There are some sectors where the U.S. industry is more decarbonized than anywhere in the world. One example is iron and steel. Our iron and steel industry is probably the cleanest in the world because it already is based largely on electric heating and electric arc furnaces and scrap-based, so it is pretty decarbonized. Other sectors are more challenging, such as chemicals and petrochemicals and food and beverage. That's where a lot of innovation is needed still.
And last question here, as far as what we're talking about, just in terms of a general transition to clean energy, I would think this would play a major part?
Absolutely, because this would be a big customer of that clean energy.
Yes.
And investors and users and our clients would want to have that. So it is a pull of that clean energy, and it would accelerate that as well.
All right, and again, EPIX is based out of ASU, helped by this Department of Energy grant. Lots going on there. Congratulations on the grant, and good luck on getting this done. I mean, this sounds like a lot of heavy lifting, if you will, with heavy manufacturing.
Yeah, indeed.
Thank you very much.
Thank you.